Today you're going to be learning about the triangle angle sum theorem. Working with this theorem, we know that the sum of all the measures of each angle in a triangle have to add up to be 180. So the definition of our theorem is that the sum of the measures of the angles of a triangle is 180 degrees. So for instance, if we're looking at an actual triangle, we have angles A, B, and C. Angle A plus angle B plus angle C will always equal 180 degrees. So let's look at an example problem. We need to figure out all of the angles for each of the numbers that are listed. Angle 1, we can look at, we have the right angle symbol, so we know angle 1 has to be 90 degrees. So that means angles 2 and 3 also have to be 90 degrees because they are supplementary angles, meaning they add to be 180 degrees to angle 1. So 2 and 3 are also 90 degrees. We can figure out angle 4. That makes a vertical angle with 130. Vertical angles are congruent, so angle 4 is 130 degrees. Another vertical angle we have is 8 and 40 degrees. So that means angle 8 is 40 degrees as well. Vertical angles are congruent. Inside we have a triangle. We have an angle that's 90 degrees, 40 degrees, and one that's missing. Based on this theorem, we know that 3 angles have to add to be 180. So that means we have 90 plus 40 plus our unknown value for 6, and that has to be 180. 90 plus 40 is 140. So when we subtract 140 to both sides, we find that it's 130. Subtract 130 to both sides, x is going to equal 50 degrees. So angle 6 is 50 degrees. Last ones we need to figure out is 9 and 7. These two are vertical, so they're going to be equal to each other. But since 40 and this angle 9, they have to add to be 180. So angle 9 will need to be 140 degrees. 40 plus 140 is 180. So angle 7 is also 140 degrees. Still sticking with triangles, let's look at the different ways we can label and classify a triangle. We can label them and classify them based on their angles and their sides. Angles, we can have equal angular, which that means all angles are congruent. Remember, the other word for congruent is equal. We can have an acute triangle, and that means all angles are less than 90 degrees, so they're acute. So they're less than 90 degrees. We can have an obtuse triangle, where only one angle is obtuse, meaning it's greater than 90, but it's also less than 180 degrees. And our last one is a right triangle, and that's where one angle is a right angle, which means it's 90 degrees. Classifying them by sides, if we have equilateral means all sides are congruent, so all sides are equal to each other. Isosceles means we have two sides that are congruent, so two sides are equal to one another. And our last one is scalene. Scalene means no sides are congruent. So let's put that to a test. Let's look at 3 different types of triangles and determine what they are. So if we know we have a triangle sides of 8, 4, and 5, that means we're labeling it based on our sides, and none of them are the same. So that means this is a scalene triangle. This one we're doing the sides again, so we're looking at these groups. we have 5, 5, and 8. So two sides are the same, so that means we're working with an isosceles triangle. And the last one, the angles. So we're looking at these four types. We have 100 degrees, 30, and 50. So since this one is obtuse, we have an obtuse triangle because one angle is greater than 90, but less than 180. Let's draw these. If we have an acute scalene, scaling means no sides are the same length. So these are all different lengths, and they're all less than 90 degrees. An isosceles right triangle. Right triangle means we know we have a 90-degree angle. Isosceles says we have two sides that are congruent to each other. So this would be an isosceles right triangle. Obtuse, meaning we have an angle greater than 90, less than 180, so this is bigger than 90, and each side is the same length. Now mine's not exactly correct drawn to scale, but if we show this, all three of these sides are congruent to each other, and this is our obtuse angle. Okay, still sticking with triangles, let's look at exterior angles. With an exterior angle, it's an angle formed by a side, and it's also an extension of an adjacent side. Adjacent just meaning connected to it. So if we look at an example, we could have this picture where we have our triangle, angle 1, 2, and 3. Angle 1 is our exterior angle because it's on the outside of our triangle. Remote interior angles are two non-adjacent, meaning they are not touching the exterior angle, and they're inside angles. They're interior angles. In this picture, angles 2 and angle 3, those are our remote interior angles. They are inside and they're not connecting or touching angle 1. The triangle exterior angle theorem tells us that we can add both of the remote interior angles and they will equal the exterior. So the formula we can use is saying that the measure of angle 1, that exterior angle, will equal the measure of angle 2 plus the measure of angle 3. So let's look at a couple of examples. If we have that the measure of angle S is 58, so we're looking up here, 58 degrees, and angle R is 63. We need to find the missing angle measure. So we want to find our exterior angle, which is angle UTS. So this is our exterior angle. Exterior, that tells us we have to do 63 plus 58. These are our two remote interior. They're inside the triangle and they're not touching our exterior. So 63 plus 58 is 121 degrees. So the angle of UTS, this is 121 degrees. Alright, last example for today. We have in this triangle a missing angle, two missing angles, and then 58 degrees. These two lines right here form vertical angles, and from last sections we should know that this is 101 degrees because those are vertical angles. Based on that information, we can say that in a triangle, three angles, angle X, angle 58, and 101 degrees have to add together to be 180 degrees. So 101 plus 58 is plus 159 equals 180. So when we subtract 159 to both sides, X is going to equal 21 degrees.